Sweat glands, also called sudoriferous glands, they are found on the skin surfaces except for the nipples, parts of the external genitalia, and there are about 3 million per person. They come in two major types, eccrine or apocrine. The apocrine ones are also called merocrine. They are sweat glands, both. They contain myoepithelial cells, which are kind of a hybrid between a muscle cell and an epithelial cell. So they have the ability to contract and force the sweat into the ducts. Those eccrine or merocrine sweat glands are the most numerous type. They are abundant on the palms, the soles, the forehead. They're ducts connected to pores. Their major role is in thermoregulation, regulating heat levels. They are regulated by the sympathetic nervous system. Their secretion is called sweat, and it is about 99% water, some salts, vitamin C, some antibodies, a microbe-killing peptide called dermacidin, and a few other metabolic wastes. The apocrine glands are confined to the axillary and anogenital areas. They secrete a viscous, milky, or yellowish sweat. And it's that way because it also contains fatty acid and proteins. And bacteria happen to like to eat fatty acids and proteins. So when they are breaking down this sweat, we get what we commonly refer to as body odor. They are larger than the eccrine sweat glands with ducts that empty into hair follicles, and they begin their functioning at puberty. Their true function is unknown. There's been some speculation that they may act as a sexual scent gland, but there's not a whole lot of evidence to support that. Modified apocrine glands include ceruminous glands, which line the external ear canal and secrete cerumen, or earwax, and mammary glands, which secrete milk. These sebaceous glands are the most widely distributed. They're found everywhere except thick skin, which is on palms and soles of feet. Most of them develop from hair follicles and secrete into a hair follicle. They are relatively inactive until puberty, and then they are stimulated by hormones, in particular the androgens or testosterone. They secrete sebum. Sebum is an oily holocrine secretion. It has bactericidal and bacteria-killing properties, and it helps to soften our skin and hair. Acne is usually an infectious inflammation of the sebaceous glands, resulting in pimples, pustules, or cysts. It has been associated with propinum bacterium acne infection. Whiteheads are blocked sebaceous glands. If that secretion is oxidized, the white kind of rusts and becomes a blackhead. Overactive sebaceous glands in infants can lead to seborrhea, often called cradle cap. Begins as a pink raised lesion on the scalp that can turn yellow, brown, and then flake off, shown here. The skin is the first and foremost a barrier. Its main functions include protection, body temperature regulation, cutaneous sensations, metabolic functions, blood reservoir, and excretion of waste. Protection, it is, as we discussed earlier, protects you against exposure to microorganisms, abrasion, temperature extremes, and harmful chemicals. We can break this barrier down into 3 different levels: chemical, physical, and biological. The chemical barrier: skin secretes many chemicals, such as sweat that contains antimicrobial proteins, sebum and defensins, which kill bacteria, and cells also secrete an antimicrobial defensin. One of the big things that helps protect against bacterial infection of the skin is what we refer to as the acid mantle. There's a low pH on the surface of the skin, and bacteria don't like to grow in acidic environments or low pH environments. And we can think of melanin as providing a chemical barrier against ultraviolet radiation damage. As a physical barrier, those flat, dead, keratinized cells of the stratum corneum, which are surrounded by glycolipids, block most water and water-based substances. There are some chemicals that have limited ability to penetrate the skin: lipid-soluble substances, plant oleoresins such as poison ivy, organic solvents, some salts of heavy metals, some drugs, and some drug agents, which we can also take advantage of to help carry drugs across the skin if you ever used a medication patch. As a biological barrier, the epidermis contains phagocytic cells. The dendritic cells of the epidermis engulf foreign antigens or invaders and present them to the white blood cells, activating an immune response. The dermis contains macrophages as well, and macrophages are very similar to dendritic cells in their function. They destroy and present antigens to the immune system. If organic solvents and heavy metals pass through the skin and enter the blood, multiple organ systems can be devastated, which can be lethal. So kidneys can shut down, brain can be damaged, absorption of lead can result in anemia and neurological defects. So when you are handling organic solvents or heavy metals, you should never be touched with your bare hands, because these things are not well blocked by the skin. Under normal resting body temperature, sweat glands produce about 500 milliliters of unnoticeable sweat a day. We call this insensible perspiration. Body temperature goes up, we get dilation of the dermal vessels and increased sweat gland activity. We can produce up to 12 liters, 3 gallons of noticeable sweat. This we would refer to as sensible perspiration, and that's designed to cool the body. In a cold external environment, the dermal blood vessels would constrict and the skin temperature would drop to slow passive heat loss. Cutaneous sensory receptors are part of the nervous system. They are found throughout the skin. The exteroceptors respond to stimuli from outside the body, such as temperature and touch, and free nerve endings respond to painful stimuli. Metabolically, skin can synthesize vitamin D for calcium absorption in the intestines, as long as we have exposure to ultraviolet light. Chemicals from keratinocytes can disarm some carcinogens. Keratinocytes can activate some hormones. They can convert cortisone to hydrocortisone. And skin can make an enzyme called collagenase, which aids in the natural turnover of collagen to help prevent wrinkles. Our skin can hold up to 5% of our body's total blood volume, and the skin vessels can be constricted to shunt the blood to other organs, such as when we are exercising muscles. And skin has a limited ability to get rid of nitrogenous wastes like ammonia and urea and uric acid, and they're lost through production of sweat. Okay, we'll stop there.